Okay, guys, we're moving on to probability. We're done with the data unit there. You guys did a good job on that. Basic probability and basically probability trees is what we're looking at. Okay, so do some examples. You flip a coin. Okay, you're going to see that. You'll see something like this. Probability P is going to be probability. So when you say P, parentheses, it's going to be probability of heads. Okay. So obviously that's 1/2, and probability of tails. So just realize what I'm trying to show you there is when you see P, that means probability of. P of means that. Okay, getting into the trees a little bit, you flip 2 coins in a row. Or you flip a coin and you flip another coin, however you want to think about it. But basically we got to look at 2. So it's going to say make a tree of this. I'd like you to make a tree is like this. You say, hey, the first flip, heads, tails could happen, like this. And then off of each of those, we could have heads and tails again. In other words, we could get heads on the first flip, and then off of that, we're going to do heads, tails again, because this is like the second flip, and this is another possibility down here. Could get heads, tails again. So in other words, you could get a head, head. You get a head on the first, then a tail on the first, head on the second, or tail, tail. This shows all the possibilities. So we say how many ends are there? There's 4 possibilities. Looking at how many different paths there are basically, or how many different ends are here. There's 4. So it might say, what's the probability of 2 heads in a row? Okay, it would be written out something like this, P of 2 heads in a row. Well, there's 4 possibilities here. The one that has 2 heads in a row is right here, right? So there's only 1 path out of all these, so 1 out of 4 chance that you get 2 heads in a row. Probability of 1 head and 1 tail, and it'll say in either order. Okay, so probability of getting a head and a tail basically in either order. So we're saying, okay, head, right here, head, tail, right? That's a head and a tail in either order, so it doesn't matter if it's head, tails, or tails, heads. There's 1. Here's tails, heads here. This one's tail, tail. So the ones that have a head and 1 head and 1 tail is right here, this path, and then this path. So it's 2 out of 4, which is obviously a half. So you got 50-50 chance actually of getting 1 head and 1 tail. And then the probability of 2 tails would be this path. That would be 1 out of 4. Okay, so that's what I like to do for the trees. It says 3 flips. Do one of those quick. It would actually look like this. Off of each of these is going to be another head, tail. Okay. That's a little more complicated. I don't think I'll actually put that one on your homework. Okay, you'll see these marble problems. So there's 2 red and 3 blue marbles in a jar. If I just say choose one, this is example number 2, I guess here. You choose a marble. And it says something like, what's the probability of red? Okay, that would be kind of like a basic kind of problem. Probability of getting red, well, there's 2 out of 5, right? What if it says choose 2? In other words, well, let's say choose 2 marbles with replacing. Okay, so in other words, you choose 1, you replace it. I choose the marble out, I replace it, and then I choose another one. All right, how would you look at that scenario? This is where we're going to make a tree. So the first choice, so the tree is a little more complicated. It's actually going to have 5 branches. Oh boy, might not be able to fit it on here. I'm going to go to the back, guys. So we've got 5 choices. We've got 2 reds and 3 blues. So I'd like you to draw it like this. 2 reds, 3 blues. We're not replacing it, so off of each of these, I got to draw 5 more. So this gets a little bit, give yourself some room, because these trees actually get a little bit big. Okay, off of each of these, I could say, well, the second time I could pick, there's still 2 reds and 3 blues, because I replaced it. All right, so this is the second draw out here. So take your time. I'm not going to make you do a lot of these because they are a little bit tedious to set up. Okay, and then fill all those in, 2 reds and 3 blues. All right, let's just say, it'll say something like this. What's the probability of picking 2 reds in a row? All right, I'll grab a color here so you can see what I'm looking at. 2 reds in a row. You know, I'm saying, hey, this path has 2 reds in a row. This path has 2 reds in a row, so there's 2. This path here has 2 reds in a row. And this path here, you probably can't even see my color here. Sorry, I picked the lightest color I could have, apparently. But you see, red. There's a path. There's a path. 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 So there's 4. There's only 4 of them that have 2 reds in a row. Out of how many paths are here total? Well, if I count these ends, I'll know how many paths there are. So 5, 10, 15, 20. There's 25 paths here. So out of all these different paths, the path is like this: red, red. Or this red, 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 blue, red, blue. Okay, out of all those different ways I can take, 4 out of the 25 have 2 reds in a row. Okay. Probability of 1 red and 1 blue. Again, in either order. What's the probability of get a red and a blue? Okay, 1 red and 1 blue. It could be red, blue, or blue, red. All right, I got to just count them out. I'm looking for all the ones that have RB. So we got 1, 2, 3. There's RB, 4, 5, 6. We got BR, 7, 8. Down here, 9, 10, 11, 12. So I counted 12 that had a B and an R or R and B out of 25. Okay? And then the last thing is, what if we do replace? All right, so we'll do the same problem and say 2 reds and 3 blue marbles. I'm sorry, we don't replace. Marbles, it'll say draw 2 without replacing. And I'll make the tree up here just so you can see what that would look like without replacing. All right, so we're basically got 2 reds. Make it big, 3 blues. Okay, that's our starting, choice. And then off of those we say, okay, I'm not replacing it. So I pulled a red. So what's left? I got 1 red and 3 blues left. So it's just like that. There's only 4 marbles left. Pull the red, say, okay, that means I got 1 red and 3 blues. What if I pull the blue? There's still 4 left. If I pull the blue, I'm going to have 2 red and 2 blue left. Okay, and these are all the same. 2 red and 2 blue. 2 red and 2 blue. Okay, so just be careful if it says replace or not replace, then you could answer all the same questions off of this. Just realize now, there's less. If I said just one quick one, probability of 2 reds in a row. Well, 1 here, 2 here. I think those are the only 2, right? Because these all have blues in them. So I got red, 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 red. So we're just talking 2 out of, now I feel like there's 4, 8, 12, 16, 20. 2 out of 20, which is 1/10, or 0.1, you could say, chance that you would get 2 reds in a row. So kind of unlikely, right? To get 2 reds in a row is pretty tough. Only going to happen 10% of the time. All right, it's basic probability trees. Hopefully that all makes sense to you guys.